it broke the speed limit. Let me be specific about what that sentence can and cannot mean, because this is one of those cases where the specific framing requires immediate correction before anything else can be said honestly, and the honest version of the story is more interesting than the dramatic version in ways worth taking seriously. Nothing that has ever been detected passing through the solar system has traveled faster than light. This is not a caveat, not a hedge, not an institutional disclaimer added by cautious scientists to an otherwise more exciting claim. It is the specific, foundational, experimentally confirmed, Nobel Prize certified truth of special relativity, the principle that the speed of light in vacuum is the specific maximum velocity at which any object carrying mass or any signal carrying information can travel. This principle has been tested in more specific ways, at more specific energy scales, with more specific experimental precision than virtually any other result in physics. It has never been violated by any confirmed observation. But here is what is genuinely extraordinary, what the specific phenomenon this video is pointing at actually is, and why the honest story deserves the attention the dramatic framing is trying to generate. In September 2021, the telescope array detector in Utah, specific array of 507 surface detectors spread across approximately 700 square kilometers of desert, designed to catch the specific particle showers produced when ultra-high energy cosmic rays strike Earth's upper atmosphere, recorded a specific event. A specific particle, almost certainly a specific proton or atomic nucleus, arrived at the top of Earth's atmosphere with a specific measured energy of approximately 244 exa-electron volts. The specific event was designated Amaterasu, after the Japanese sun goddess, by the specific team at the Osaka Metropolitan University that published the analysis in Science in November 2023. 244 exa-electron volts. This is a specific number that requires context to appreciate. The specific Large Hadron Collider at CERN, the specific most powerful particle accelerator ever built, the specific machine that discovered the Higgs boson, the specific instrument that represents the specific pinnacle of human engineering for producing high-energy particles, accelerates protons to a maximum energy of approximately 6.5 tera-electron volts. One particle of Amaterasu energy carries approximately 37 million times more energy than a proton at the LHC's maximum. The Amaterasu event is one of only 3 ultra-high energy cosmic rays ever detected above 200 exa-electron volts. The first was the Oh My God particle, a specific event detected in 1991 by the Fly's Eye detector in Utah, estimated at approximately 320 exa-electron volts, the specific highest energy cosmic ray ever recorded. The second was detected by the Agasa array in Japan. And now, Amaterasu. These particles did not travel faster than light. Nothing does. But they traveled so close to the speed of light, so specifically, so quantifiably close, that the difference between their speed and the speed of light is one of the most extraordinary numbers in physics. And where they came from, what produced them, and how they got here are specific, genuinely unsolved questions that are among the most important in current high-energy astrophysics. It broke the speed limit not by exceeding it, but by approaching it more closely than any macroscopic object ever detected. The speed limit of the universe is 299,792,458 meters per second. The Amaterasu particle was traveling at 299,792,457.999999999999999999999 meters per second. The specific difference, less than 1 part in 10, 24 below the speed of light. Let me take you to the specific physics that makes ultra-high energy cosmic rays so extraordinary, because understanding what makes them interesting requires understanding what cosmic rays are, where they come from, and why producing them at the energies the telescope array has detected is specifically, genuinely difficult. A cosmic ray is a specific high-energy charged particle, most commonly a proton or an atomic nucleus traveling through space at relativistic velocities. The specific term cosmic ray is historical and slightly misleading. They are particles, not rays in the electromagnetic sense. They arrive at Earth from all directions, continuously, day and night, through all weather. The specific low-energy cosmic rays particles with energies of a few billion electron volts arrive at a rate of approximately 1 per square centimeter per second. They are produced primarily by our own sun and by the shock waves of supernova remnants in the Milky Way. But the specific ultra-high energy cosmic rays particles with energies above approximately 1 exa-electron volt, a billion electron volts, are a specific different population. They are rare. The specific most extreme events like Amaterasu arrive at the rate of approximately 1 per square kilometer per century. Their specific sources are not established. Their specific acceleration mechanism is not fully understood, and their specific energy is so extreme that the specific physics of their production and propagation presents specific genuine challenges to current models. The specific energy of the Amaterasu particle, 244 exelectron volts, has a specific physical significance that makes its origin particularly puzzling. In 1966, two specific theoretical physicists, Greisen in the United States and Zatsepin and Kuzmin in the Soviet Union, independently predicted a specific upper limit on the energy of cosmic rays that can travel cosmological distances through the universe. The specific prediction, now called the GZK limit after the three physicists, is that protons with energies above approximately 50 exa-electron volts interact with the specific photons of the cosmic microwave background. The specific 2.7 Kelvin thermal radiation that fills the entire universe through a specific reaction that produces pions and loses energy. The specific mean free path for this energy loss is approximately 160 million light years. The specific implication is direct. If a proton has an energy above 50 exa-electron volts, it cannot have traveled more than approximately 160 million light years through the specific CMB photon background without losing most of its energy through pion production. The specific Amaterasu particle, with its specific energy of 244 exa-electron volts, therefore must have originated from a specific source within approximately 160 million light years of Earth. 160 million light years. This is a specific bounded volume of the universe, a specific region of the local cosmic web that contains specific known galaxy clusters, specific known galaxy groups, and specific known potential cosmic ray sources. If the Amaterasu particle's source can be identified, if the specific direction from which it arrived can be traced back to a specific astrophysical object, the specific mystery of its production can potentially be resolved. Let me now take you to the specific puzzle that makes the Amaterasu particle and other ultra-high energy cosmic rays genuinely mysterious, the specific pointing problem. Charged particles moving through magnetic fields are deflected. The specific amount of deflection depends on the specific particle's charge, the specific particle's momentum, and the specific strength of the magnetic field. For a proton at Amaterasu energies, so massive, so fast, with such specific enormous momentum, the specific deflection by the galactic magnetic field and the specific intergalactic magnetic field is small compared to lower energy cosmic rays. The specific arrival direction of an ultra-high energy cosmic ray should point back toward its source with reasonable accuracy. This specific property, that ultra-high energy cosmic rays should point back toward their sources, is what makes the Amaterasu event specifically puzzling. The specific telescope array team analyzed the specific arrival direction of the Amaterasu event and traced it back through the specific known galactic and extragalactic magnetic fields to its most likely source region. The specific region it points toward is a void, a specific large underdense region of the local universe with no obvious candidate sources. The specific most massive galaxies, the specific most energetic active galactic nuclei, the specific most energetic galaxy clusters are in other directions. The specific apparent origin direction of one of the most energetic particles ever detected points toward a specific region of the universe that doesn't obviously contain anything capable of producing it. This specific result, published in the specific November 2023 science paper by the Telescope Array Collaboration, is the specific reason the Amaterasu event has generated genuine scientific excitement. Not because the particle traveled faster than light, not because it broke any physical law, but because it specifically appears to come from somewhere that current astrophysical models cannot explain. The specific possible explanations fall into several categories. The specific first is that the specific pointing is wrong, that the specific magnetic fields through which the particle traveled are not as well characterized as the specific reconstruction assumes, and the specific actual source is in a different direction where specific plausible accelerators exist. The specific intergalactic magnetic field is poorly constrained in the specific local void regions, and specific, relatively small errors in its specific configuration could significantly deflect the specific reconstructed arrival direction. The specific second possibility is that the specific apparent source region actually does contain a specific energetic astrophysical object that has not been cataloged, a specific relatively nearby but specific faint galaxy with a specific highly active nucleus, a specific compact binary system, a specific magnetar, or other specific compact object that is capable of the specific extreme particle acceleration required. The specific third possibility, and the specific most theoretically radical, is that the specific ultra-high energy cosmic ray was produced by a specific exotic process that current physics does not fully account for. Specific decays of specific super heavy dark matter particles, specific topological defects from the specific early universe, specific processes that the specific GZK limit analysis assumes don't occur at these specific energies but actually do. Let me now tell you about the specific mechanism by which any astrophysical object could accelerate a particle to Amaterasu energies, because the specific physics of extreme particle acceleration is one of the most interesting and most challenging frontiers in high energy astrophysics. The specific dominant theoretical mechanism for cosmic ray acceleration is called diffusive shock acceleration, or the Fermi mechanism after Enrico Fermi, who proposed a related idea in 1949. In this specific mechanism, a charged particle bounces back and forth across a specific shock front, the specific boundary between fast-moving plasma and slower-moving plasma, produced by a specific explosive event or a specific powerful jet. Each specific crossing of the shock front gives the particle a specific small energy boost. Over specific many crossings, the particle's energy grows by a specific multiplicative factor each time, producing the specific power law energy spectrum that cosmic rays are observed to follow. For the specific most energetic cosmic ray accelerators, the specific sources capable of reaching Amaterasu energies, the specific shock must be both specific large enough and specific fast enough that the particle can gain sufficient energy before escaping. The specific product of the specific magnetic field strength and the specific physical size of the specific accelerator, the specific Hiller's criterion, sets the specific maximum energy achievable by a specific given source. The specific astrophysical objects capable of meeting the Hiller's criterion for Amaterasu level energies are few. They include the specific active galactic nuclei with the most powerful jets, the specific blazars and radio galaxies whose specific magnetic fields and specific physical extents could, in principle, reach these specific energies. The specific gamma ray bursts, the specific most energetic explosions in the specific universe could briefly achieve the specific necessary conditions. And the specific starburst galaxies, the specific regions of intense star formation with specific powerful winds and specific strong magnetic fields are specific possible but specific less energetically extreme candidates. The specific problem with all of these candidates for the Amaterasu event is the specific pointing. None of the specific known blazars, radio galaxies, or starburst galaxies in the specific direction of the Amaterasu arrival within the specific angular uncertainty of the reconstruction is an obvious candidate for producing a specific 244 exa electron volt proton that reaches Earth. This specific non-identification is not unique to Amaterasu. The specific oh my God particle detected in 1991 also showed no obvious source in its specific pointing direction. The specific mystery of what produces the specific most extreme cosmic rays and why their specific arrival directions don't obviously correspond to the specific known most energetic astrophysical objects has been one of the most actively debated questions in high energy astrophysics for more than 30 years. Let me now tell you about the specific observational progress that is most directly relevant to eventually resolving the Amaterasu mystery, the specific planned extensions of the telescope array and the specific Auger Observatory in Argentina. The specific current telescope array with its specific 507 surface detectors covering specific 700 square kilometers detects approximately one event per year above 100 exa-electron volts. This specific rate is too low to build the specific statistical samples needed to confidently identify sources by correlating specific multiple arrival directions with specific astrophysical objects. The specific pointing uncertainty of individual events approximately 2 to 3 degrees further complicates the specific source identification for any specific single event. The specific telescope array times 4 expansion currently under construction will quadruple the specific detector area to approximately 2,800 square kilometers by adding specific additional surface detectors to the specific existing array. The specific 4-fold increase in area will produce a specific 4-fold increase in the specific event rate above 100 exa-electron volts from approximately 1 to approximately 4 per year. Over a specific 10-year operation, this specific expanded array will accumulate approximately 40 extreme events, sufficient for the specific statistical analysis needed to test specific source hypotheses at specific meaningful confidence levels. The specific Pierre Auger Observatory in Argentina, the specific other major ultra-high energy cosmic ray detector, located in the Mendoza province with an active area of approximately 3,000 square kilometers, has been producing the specific largest and specific most uniform sample of ultra-high energy cosmic rays in the specific southern sky. The specific Auger Prime upgrade, completed in 2022, has added specific surface scintillators on top of the specific water Cherenkov detectors, providing specific additional discrimination between specific different cosmic ray primary compositions, whether the specific arriving particle is a specific proton, a specific helium nucleus, a specific oxygen nucleus, or a specific iron nucleus. The specific primary composition is directly relevant to the specific source identification problem. Protons are deflected less by magnetic fields than heavier nuclei. They point back toward their sources more accurately. If the specific ultra-high energy cosmic rays are predominantly protons, the specific pointing is more reliable. If they are predominantly heavy nuclei, iron nuclei, which carry specific 26 times the deflection of protons, the specific pointing reconstruction is significantly less reliable, and the specific source directions are more uncertain. The specific Auger Prime composition measurements at the specific highest energies are suggesting a specific trend toward heavier composition as the energy increases potentially iron nuclei rather than protons at the specific extreme. Energies. If confirmed, this would significantly relax the specific pointing constraints and could explain why the specific apparent origin directions of events like Amaterasu don't obviously correspond to specific known sources. The specific arrival directions may be substantially deflected from the specific true source directions. Let me now tell you about something that connects the ultra-high energy cosmic ray story to the specific broader cosmological picture that this series has been building. The specific GZK limit, the specific energy horizon above which protons cannot travel more than approximately 160 million light years, is itself one of the most specific, most direct confirmations of the specific cosmic microwave background. The CMB that the Planck satellite maps with such specific, extraordinary precision at the specific large-scale cosmological level is also the specific medium through which the specific highest energy cosmic rays cannot propagate without energy loss. The specific same 2.7 Kelvin photon background that encodes the specific acoustic oscillations of the early universe is also the specific barrier that limits the specific travel distance of the specific most energetic particles the universe produces. This specific connection between the specific cosmological photon background and the specific high-energy particle physics of the most extreme cosmic ray events is one of the specific, most elegant examples of the specific unity of physics at specific, very different scales. The CMB was produced 380,000 years after the Big Bang. The Amaterasu particle was accelerated wherever it was accelerated within the specific past few hundred million years, given the specific GZK constraint. The specific same photon field connects both phenomena. The specific additional connection involves the specific magnetic fields of the cosmic web that we discussed in the previous conversations. The specific intergalactic magnetic field that deflects ultra-high energy cosmic rays and complicates the specific pointing reconstruction is the specific same field whose specific origin, primordial or astrophysical, one of the specific key science goals of the specific FRB rotation measure program we discussed. The specific, better we understand the specific intergalactic magnetic field from specific FRB observations, the specific, more accurately we can reconstruct specific cosmic ray arrival directions. The two specific observational programs, specific FRB rotation measures, and specific ultra-high energy cosmic ray pointing are specific complementary probes of the specific same physical quantity. It broke the speed limit in the specific sense that the Amaterasu particle was traveling at a specific velocity so close to the speed of light that the specific difference is measurable only in the specific most extreme decimal places, not exceeding the limit. Approaching it more closely, than any specific macroscopic object we have ever detected, and in doing so, providing a specific, genuine, astrophysically important puzzle, where it came from, what produced it, how it reached us, that the specific next generation of cosmic ray detectors is specifically designed to resolve. Let me close this first part with something that honestly connects the specific Amaterasu event to the specific broader question of what the fastest things in the universe actually are and what the specific physics of extremely high velocities tells us about the specific nature of space, time, and energy. The specific Amaterasu particle's speed, 299,792,457.999999999999999999999 meters per second is extraordinary, not just as a specific number, but as a specific demonstration of a specific physical principle. In special relativity, as a specific particle's velocity approaches the specific speed of light, the specific amount of energy required to further increase the velocity grows without bound. The specific kinetic energy of a particle at velocity v is not the specific simple Newtonian formula of half mass times velocity squared, but a specific relativistic formula that diverges as v approaches c. To actually reach c would require specific infinite energy, which is why c is the specific upper bound for any specific massive object. The specific Amaterasu particle, with its specific 244 exa-electron volts of energy, is carrying approximately 4 times 10, 7 times its specific rest mass energy in the form of specific kinetic energy. The specific Lorentz factor, the specific ratio of the particle's total energy to its specific rest mass energy, is approximately 2.5 times 10^11. The specific particle experiences time dilation by this specific same factor from the specific particle's perspective. If such a perspective can be meaningfully defined, the specific 160 million light-year journey from its specific source to Earth is compressed into the specific equivalent of approximately a few hours of proper time. A journey of 160 million light-years in a few hours of proper time. This is the specific most extreme time dilation achieved by any specific known object, not by technology, not by proximity to a black hole, but by specific kinetic energy alone, by the specific fact that the particle is moving fast enough that the specific relativistic time dilation compresses its specific proper time by a factor of 250 billion. This is the specific speed limit the Amaterasu particle approached, not the limit of the speed itself. It did not break that, but the specific limit of what the specific kinetic energy of a specific particle can compress time to. The specific closest approach to the speed of light of any specific detected macroscopic object in the specific history of physics. In part 2, I want to go deeper into the specific multi-messenger astronomy program that ultra-high energy cosmic rays are part of, into the specific theoretical models for their acceleration that the Amaterasu pointing problem is constraining, and into something I find genuinely extraordinary, the specific connection between the Amaterasu event and the specific neutrino astronomy program, and what the specific detection of ultra-high energy neutrinos from the specific same sources as cosmic rays would reveal about the specific production mechanism. It broke the speed limit, not by exceeding it, by approaching it specifically, precisely, at 244 exa-electron volts of kinetic energy, more closely than any macroscopic object ever detected. And in doing so, posing one of the specific, most important unresolved questions in current high-energy astrophysics. Where did it come from? So we'd arrived at this place where the Amaterasu event, the specific 244 exa-electron volt cosmic ray detected by the telescope array in September 2021, one of only 3 particles ever recorded above 200 exaelectron volts is genuinely puzzling, not because it violated any physical law, but because its specific reconstructed arrival direction points toward a region of the local universe that does not obviously contain the kind of astrophysical object capable of producing it, where the specific GZK limit constrains its origin to within approximately 160 million light years, where the specific composition, uncertainty, whether the arriving nucleus was a proton, iron, or something in between, significantly affects how precisely the arrival direction points back to the source. And where the specific fourfold expansion of the telescope array and the specific Auger Prime upgrade in Argentina are building the statistical power needed to eventually resolve what produces these extraordinary particles. Now I want to go deeper into the specific multi-messenger program that ultra-high energy cosmic rays are part of, and what the detection of ultra-high energy neutrinos from the same sources would reveal, into the specific theoretical models for extreme particle acceleration that Amaterasu is constraining, and into something genuinely important, the specific recent ice cube neutrino astronomy results that are for the first time beginning to identify the sources of at least some fraction of the high energy cosmic ray population. Let me start with neutrinos, because they are the specific key to resolving the cosmic ray source mystery. The specific challenge of identifying ultra-high energy cosmic ray sources is fundamentally a magnetic field problem. Charged particles, protons, helium nuclei, iron nuclei are deflected by every magnetic field they encounter on their journey from source to Earth. Even at Amaterasu energies, where the deflection is relatively small, the cumulative deflection through the specific poorly characterized intergalactic magnetic field introduces specific angular uncertainty that makes precise source identification difficult. Neutrinos have no such problem. They are electrically neutral, they are not deflected by magnetic fields, they travel from their specific source to Earth in a specific straight line, pointing back to their origin with essentially perfect angular accuracy. And they interact so weakly with matter that they pass through the specific entire universe without absorption. They are not subject to anything analogous to the GZK limit that constrains proton propagation. The specific connection between neutrinos and cosmic rays is direct and quantitative. When an ultra-high energy proton interacts with photons or gas near its specific source in the specific dense environment of an active galactic nucleus jet or a gamma-ray burst or a starburst, galaxy pions are produced. These specific pions decay into both specific gamma rays and specific neutrinos. The specific ratio of neutrino to gamma ray production is calculable from specific known particle physics. If a source produces ultra-high energy cosmic rays through hadronic interactions, protons colliding with photons or gas, it must also produce ultra-high energy neutrinos at a specific predicted rate. This means that a specific neutrino telescope pointing at the same source as an ultra-high energy cosmic ray would provide the specific, most direct confirmation that a specific astrophysical object is genuinely accelerating cosmic rays. The specific neutrino telescope that is most relevant to this program is IceCube, the specific cubic kilometer of Antarctic ice, instrumented with specific more than 5,000 photomultiplier tubes, buried between 1,450 and 2,450 meters below the South Pole ice surface, detecting the specific faint blue light of Cherenkov radiation produced when high-energy neutrinos interact with the ice. Let me take you to the specific IceCube results that have most directly advanced our understanding of cosmic ray sources, because the specific progress over the past 3 years has been transformative. IceCube has been operating since 2010, and has accumulated one of the most important data sets in the history of high-energy astrophysics. In 2013, the collaboration announced the first detection of a high-energy astrophysical neutrino signal, a specific diffuse flux of neutrinos with energies above 100 tera-electron volts arriving from all directions, inconsistent with the atmospheric neutrino background and requiring an astrophysical origin. This specific discovery, the first direct detection of cosmic neutrinos since SN 1987A, established that the universe is filled with high-energy neutrinos whose sources were initially unidentified. The specific first significant source identification came in 2018. IceCube detected a specific 290 tera-electron volt neutrino designated IceCube 170922A, and rapid follow-up observations by the Fermi Gamma Ray Space Telescope and other instruments identified a specific active galactic nucleus called TXS0506 plus 056 as the specific likely source. TXS0506 plus 056 is a specific blazar, an active galactic nucleus with a specific relativistic jet-oriented approximately toward Earth at a redshift of approximately 0.34, approximately 4 billion light-years away. At the time of the neutrino detection, TXS0506 plus 056 was in a specific flaring state, producing specific enhanced gamma-ray emission consistent with the specific hadronic interaction models that predict simultaneous neutrino production. This specific multi-messenger detection, a specific neutrino from a specific direction, a specific gamma-ray flare from the specific same direction, a specific known blazar at that specific position, was the specific first strong evidence that at least some fraction of the high-energy neutrino background originates in blazars. Not a definitive identification, the specific statistical significance was approximately 3.5 sigma, sufficient to be taken seriously, but not to claim a discovery, but a specific, important, directional result. The specific subsequent analysis, searching IceCube's archival data for historical neutrino emission from TXS 0506 plus 056, found a specific excess of approximately 13 neutrinos from the specific source, direction in a specific 110 day window in 2014 to 2015, before the 2018 flare. This specific historical excess, while not coincident with a specific observed gamma-ray flare, is consistent with the blazar being a specific intermittent neutrino source that was active before the specific monitoring programs detected its gamma-ray activity. Let me now tell you about the specific 2023 IceCube result that is most directly relevant to the cosmic ray source problem, the specific identification of the Seyfert galaxy NGC 1068 as a high-energy neutrino source. NGC 1068, also known as Messier 77, is a specific Seyfert II galaxy, approximately 47 million light-years from Earth in the constellation Cetus. It is one of the specific closest and specific most studied active galactic nuclei in the sky, a specific galaxy with a specific supermassive black hole actively accreting material surrounded by a specific dense torus of gas and dust that obscures the specific nuclear region in visible light but allows infrared and X-ray observation. In November 2022, the IceCube collaboration published a specific analysis of 10 years of data finding a specific excess of high-energy neutrinos from the specific direction of NGC 1068 at a specific statistical significance of 4.2 sigma, approaching but not quite reaching the specific 5 sigma threshold conventionally required for a discovery claim. The specific neutrino flux from NGC 1068 is approximately 3 times larger than what the specific gamma ray emission from the same source would predict from standard hadronic interaction models. This specific discrepancy, too many neutrinos for the observed gamma rays, is scientifically important. In the specific standard model for hadronic cosmic ray acceleration, the specific ratio of neutrinos to gamma rays is fixed by specific particle physics. If a source produces specific more neutrinos than gamma rays, either the specific gamma rays are being absorbed within the source, making the source optically thick to gamma rays, or the specific production mechanism is different from the specific standard hadronic model. For NGC 1068, the specific most likely explanation is that the specific dense gas and dust surrounding the specific active nucleus absorbs the specific gamma rays before they can escape, but the specific neutrinos, interacting only weakly, escape freely. The specific nucleus of NGC 1068 is a specific cosmic ray factory embedded in a specific thick blanket of material that absorbs the photons while allowing the neutrinos to escape. This specific interpretation has a specific and important implication for the cosmic ray source identification problem. If specific active galactic nuclei like NGC 1068, surrounded by specific dense obscuring material, are producing cosmic rays and neutrinos efficiently, but with specific absorbed gamma ray signatures, then the specific gamma ray-based surveys that have traditionally been used to identify candidate cosmic ray sources are blind to this class. The specific sources are cosmic ray accelerators that are electromagnetically hidden, only revealed through the specific neutrino channel. This specific possibility that a significant fraction of the ultra-high energy cosmic ray background is produced by specific sources that are invisible in gamma rays would explain why the specific arrival directions of events like Amaterasu don't obviously correspond to specific known gamma ray bright objects. The specific accelerators may be there in the specific direction the cosmic ray points, but invisible in every electromagnetic channel we've surveyed. Let me now take you to the specific theoretical framework that accommodates all of these specific observations and that provides the specific, most complete current picture of where ultra-high energy cosmic rays come from. The specific Unger-Ferrigno unified model developed by Michael Unger, Glenis Farrar, and collaborators and published in Physical Review D in 2015 and extended in subsequent papers, proposes that the specific observed ultra-high energy cosmic ray spectrum composition and arrival direction distribution can be simultaneously explained by a specific population of sources that accelerate heavy nuclei, specifically iron and intermediate mass nuclei, rather than protons to the specific extreme energies observed. The specific reason heavy nuclei are favored over protons in this model involves the specific coherence of multiple observations. The specific Auger prime composition measurements show a specific trend toward heavier composition as the energy increases above approximately 10 exa-electron volts. The specific arrival direction distribution of events above the GZK threshold shows a specific isotropy that is more consistent with heavy nuclei, whose specific larger deflection smears out any source anisotropy than with protons, which should point more clearly toward their sources. The specific production sites in this model are the specific most extreme astrophysical environments, the specific jets of powerful radio galaxies, the specific regions near the specific most massive active galactic nuclei, possibly the specific magnetospheres of specific rapidly rotating neutron stars. The specific maximum energy achievable in these environments for iron nuclei with their specific 26 times higher rigidity can reach 26 times the maximum proton energy, making the specific 244 exa-electron volt Amaterasu event achievable from a specific source that could only accelerate protons to approximately 10 exaelectron volts. If Amaterasu is an iron nucleus rather than a proton, the specific arrival direction would be deflected approximately 26 times more by magnetic fields than a proton would be, making the specific apparent origin direction potentially far from the specific true source. A specific heavy nucleus arriving from a specific void would not necessarily mean the source is in the void. The specific true source could be in a completely different direction, with the specific particle having been deflected by the specific poorly mapped intergalactic magnetic field during its specific journey. The specific Auger prime upgrades, specific composition measurements at the specific highest energies, which will determine whether the specific most extreme events are protons or heavy nuclei, will be the single most important discriminant between the specific competing source models and the specific different pointing interpretations. Let me now tell you about the specific future of the multi-messenger cosmic ray program, the specific instruments and the specific measurements that will resolve the source mystery within the next decade. The specific IceCube Gen 2 detector, the planned upgrade to the existing IceCube array, expanding the instrumented volume from 1 cubic kilometer to approximately 8 cubic kilometers, will dramatically increase IceCube sensitivity to high-energy neutrino sources. The specific larger volume provides both a specific larger effective area for detecting high-energy neutrinos and a specific better angular resolution from the specific increased number of photomultiplier tubes sampling each neutrino. Interaction. With IceCube, Gen 2 operating for 10 years, the specific number of detected neutrinos from NGC 1068 type sources is expected to be sufficient to confirm the specific source identification at greater than 5 sigma and to identify specific additional sources in the specific same class. The specific combination of IceCube Gen 2 neutrino source identifications with the specific telescope array times 4 cosmic ray arrival direction analysis will provide the specific most direct test of whether the specific neutrino sources and the specific ultra high energy cosmic ray sources are the specific same population if the specific neutrino sources identified by IceCube Gen 2 correspond directionally to specific concentrations of ultra-high energy cosmic ray events in the telescope array times 4 data, the specific cosmic ray source problem will be substantially resolved. The specific sources are specific obscured active galactic nuclei. The specific composition is specific heavy nuclei, explaining the specific poor pointing, and the specific mechanism is specific hadronic acceleration in specific dense nuclear environments. If the specific neutrino sources and the specific cosmic ray directions don't correspond to the specific source, mystery will be sharpened into a more specific question about why the specific highest energy events come from specific directions different from the specific neutrino bright sources. The specific Cherenkov telescope array CTA, currently under construction in Chile and on the Canary Islands, will provide the specific most sensitive gamma ray observatory ever built for very high energy gamma rays above approximately 20 giga electron volts. The specific CTA's combination of specific angular resolution and specific sensitivity will enable the specific detailed mapping of gamma ray emission from specific candidate cosmic ray sources and the specific search for the specific absorbed gamma ray signatures expected from the specific dense environment accelerators that the specific NGC 1068 result suggests. Let me now address something that I think deserves careful treatment: the specific role that the Amaterasu event plays in the broader scientific context and what the specific honest assessment of its significance is. The Amaterasu event is genuinely scientifically important. A specific 244 exelectron-volt cosmic ray is among the specific highest energy particles ever detected, the specific third confirmed event above 200 exelectron volts in the specific history of cosmic ray physics. Its specific detection by the specific upgraded telescope array with a specific improved energy resolution and the specific pointing reconstruction that the specific expanded array provides represents a specific advance in the specific observational characterization of the specific most extreme cosmic ray events. But the specific broke the speed limit framing requires honest correction that the specific scientific paper itself published in Science does not make. The specific particle did not travel faster than light. The specific scientific paper says nothing about faster than light travel. The specific claim in the headline is specifically false and specifically misleading in a specific way that obscures rather than illuminates the specific genuine scientific interest of the event. The specific genuine scientific interest is this: a particle of this specific energy arriving from the specific direction it came from points toward a region of the local universe without an obvious specific accelerator. This specific puzzle, not the specific false claim about superluminal travel, is the specific reason the Amaterasu event deserves attention. And the specific resolution of this specific puzzle through the specific combination of specific composition measurements, specific neutrino source identifications, and specific multi-messenger correlations will advance our specific understanding of the specific most extreme particle acceleration in the universe in a specific and important way. The specific honest story is more interesting than the specific false story. The specific physical mystery is more puzzling than the specific fake faster than light claim. And the specific scientific program working toward its resolution is more impressive than any dramatic framing can convey. Let me now tell you about what the specific Amaterasu particle's specific extraordinary energy tells us about the specific universe as a particle accelerator, because this specific perspective reveals something genuinely remarkable about the specific physical processes operating in the specific most extreme astrophysical environments. The specific Large Hadron Collider at CERN accelerates protons to 6.5 tera-electron volts using specific superconducting magnets in a specific 27-kilometer circular tunnel, requiring a specific dedicated technical infrastructure with a specific annual electricity budget exceeding 1 terawatt-hour. The specific most extreme cosmic ray events, the specific oh my god particle, the specific Amaterasu event carries specific energies millions of times higher than the LHC achieves, produced by specific astrophysical objects using no specific engineered technology. The specific universe is accelerating particles to specific energies that the specific, most sophisticated human technology cannot approach in specific astrophysical environments that operate on specific, completely different physical principles from any specific human particle accelerator. This specific comparison is not intended to diminish the specific achievement of the LHC. It is a specific monument to human engineering and scientific vision, but it highlights a specific and important truth about high-energy astrophysics. The specific universe contains specific natural laboratories operating at specific energy scales permanently beyond the specific reach of any specific human accelerator. The specific only way to access these specific energy scales experimentally is to catch the specific particles the specific universe produces and analyze them as they arrive at Earth. The specific cosmic ray physics program, the specific telescope array, the specific Pierre Auger observatory, the specific future grand detector, and specific Poema satellite is therefore not just studying an interesting phenomenon, It is conducting particle physics experiments at specific energies that no other technique can access. The specific interactions of ultra-high energy cosmic rays with a specific CMB photon background, the specific reactions that produce the specific GZK limit are specific particle physics processes occurring in the specific energy regime between approximately 50 and 1,000 exaperi electron volts that the specific universe itself is performing in its own natural laboratory. Understanding the specific composition, the specific sources, and the specific propagation of the specific most extreme cosmic rays is therefore simultaneously astrophysics, understanding what specific objects produce them, and particle physics accessing specific energy regimes permanently beyond the specific reach of any specific human accelerator. Let me close this second part with something that connects the ultra-high energy cosmic ray story to the specific theme of multi-messenger astronomy that has appeared throughout this series. The specific, most scientifically productive era in astrophysics is the one we are currently entering. The specific multi-messenger era in which the same physical phenomena are observed simultaneously in specific gravitational waves, specific neutrinos, specific electromagnetic radiation across the full spectrum, and specific cosmic rays. The specific GW 170817 neutron star merger detection was the specific first major demonstration of this approach. The specific TXS 0506 plus 056 Blazer identification was the specific first cosmic ray multi-messenger result. The specific NGC 1068 neutrino detection is the specific second. The specific Amaterasu event represents the specific current frontier of the specific cosmic ray component of this multi-messenger program. It is the specific event that most urgently requires the specific neutrino and specific gamma ray follow-up that will either identify its specific source or deepen its specific mystery, the specific next decade with the specific ice cube, Gen 2 expansion, the specific telescope array times 4 completion, the specific CTA beginning operations, and the specific proposed Poema satellite providing specific space-based cosmic ray detection will transform the specific field from the specific current era of specific individual extraordinary events to a specific statistical era of specific populations, specific source classes, and specific multi-messenger correlations. The specific fastest particle ever detected, traveling at 299,792,457.99, 9999, 99999, 999999999 meters per second, carrying the specific equivalent of a baseball thrown at 100 kilometers per hour in the specific kinetic energy of a single proton or nucleus, is asking a specific question that the specific next generation of instruments will answer. Where did it come from? In part 3, I want to bring everything together into the complete picture of what the Amaterasu event and the broader ultra-high energy cosmic ray program mean for our understanding of the universe's most extreme environments, for what the specific resolution of the source mystery will reveal about particle acceleration physics, and for what I think is the most profound and most personally significant implication of the entire cosmic ray story. What it means that the universe is continuously bombarding Earth with particles of extraordinary energy, that we have built instruments sensitive enough to catch individual ones, and that each specific catch is a specific message from the specific most energetic processes occurring anywhere in the specific observable cosmos. It broke the speed limit, not by exceeding it, by approaching it more closely than any macroscopic object ever detected. And that specific approach, that specific closeness to the specific absolute boundary of what physics permits is the specific most extraordinary thing about the specific Amaterasu particle, and the specific most important reason its specific origin deserves the specific scientific attention it is receiving. So we'd arrived at this place where the Amaterasu particle, the specific 244 exa-electron-volt cosmic ray detected by the telescope array in September 2021, is genuinely puzzling for its specific lack of an obvious source in its reconstructed arrival direction, where the specific multi-messenger program combining ice cube neutrino observations with cosmic ray arrival direction analysis is beginning to identify specific source classes, including obscured active galactic nuclei like NGC 1068, and where the specific composition, uncertainty, whether Amaterasu is a proton or a heavy nucleus, is the single most important discriminant between specific competing source models. Now I want to bring it all the way home into what the ultra-high energy cosmic ray program means for our understanding of the universe's most extreme particle acceleration environments, into what the specific resolution of the source mystery will reveal, and into what I think is the most important and most personally significant implication of the entire story. Let me start with what the universe is telling us through these particles. Every ultra-high energy cosmic ray that reaches Earth is a message, not a coded message, not an intelligent signal, a specific physical message in the most literal sense. A particle that left a specific location in the universe, traveled through the specific intergalactic medium for a specific amount of time, survived the specific interactions with the specific CMB photon background, entered the specific Earth's atmosphere, and produced a specific shower of secondary particles that activated the specific detectors of the telescope array or the Pierre Auger Observatory. The specific physical properties of that particle, its specific energy, its specific arrival direction, its specific chemical composition are the specific content of the message. They encode information about the specific source environment, the specific acceleration mechanism, the specific magnetic fields traversed, and the specific propagation physics experienced over the specific journey. Reading this message is what the specific cosmic ray program does, not passively, actively, systematically, with specific instruments designed to extract the specific maximum information from each specific particle. The specific challenge is that the message is damaged in transit. The specific magnetic fields through which the particle travels deflect its specific path, obscuring the specific source direction. The specific CMB interactions drain specific energy from the specific highest energy protons, modifying the specific original energy and potentially changing the specific particle type through secondary production. The specific Earth's atmosphere converts the single specific primary particle into a specific shower of billions of secondary particles, from which the specific primary particle's properties must be reconstructed through specific statistical inference. This is the specific detective work of ultra-high energy cosmic ray physics, working backward from the specific observed shower to the specific primary particle to the specific source. With specific incomplete information, specific uncertain magnetic field maps, and specific limited event statistics. But the specific detective work is succeeding. The specific identification of NGC 1068 as a specific neutrino source, and by inference a specific cosmic ray source, is a specific concrete result. The specific TXS 0506 plus 056 blazar identification is a specific concrete result. The specific Auger prime composition trend toward heavy nuclei at the highest energies is a specific concrete result. The specific pattern of these results is converging on a specific coherent picture. Let me now tell you about what I think is the most important scientific conclusion that the current data is pointing toward, not definitively established, but the specific direction that the specific evidence is most consistently indicating the specific most extreme cosmic rays events like Amaterasu and the oh my god particle above 200 exa-electron volts are most likely heavy nuclei, probably iron or near iron, accelerated in the specific most extreme astrophysical environments in the specific local universe within the GZK horizon. The specific apparent origin directions of these events, when adjusted for the specific large magnetic deflections that iron nuclei experience, would point towards specific concentrations of powerful active galactic nuclei or starburst galaxies within the specific relevant volume. The specific moderate energy, ultra high energy cosmic rays between approximately 10 and 100 exa-electron volts show a specific mixed composition, with the specific proportion of heavy nuclei increasing with energy. The specific sources of these specific events include a specific diverse population of accelerators, possibly including the specific same obscured active galactic nuclei revealed by IceCube's NGC 1068 detection, and the specific lower energy cosmic rays below approximately 1 exa-electron volt are predominantly from specific galactic sources, the specific shock waves of supernova remnants, possibly the specific central regions of the Milky Way. This specific three-regime picture, specific galactic sources at low energy, specific diverse extragalactic sources at intermediate energy, specific most extreme point sources at the highest energies, is the specific framework that the current data most consistently supports. It is not confirmed at the specific level of individual source identifications, but the specific statistical patterns in the specific energy spectrum, the specific composition measurements, and the specific arrival direction distributions are all consistent with it. The specific resolution of the Amaterasu puzzle, identifying the specific source responsible for this specific particle, will fit into this specific picture either by finding a specific previously uncatalogued or underappreciated source in the specific void region, or by demonstrating that the specific composition is heavy enough that the specific true source is in a specific, completely different direction where specific known powerful accelerators exist. Let me now tell you about the specific, broader physical significance of whatever produces ultra-high energy cosmic rays, because the specific physics of the acceleration mechanism itself is one of the specific most important unsolved problems in theoretical astrophysics. The specific Hillas criterion tells us the specific combination of magnetic field and size required to accelerate a particle to a given energy. For Amaterasu energies 244 exa-electron volts for a proton, or approximately 10 exa-electron volts for an iron nucleus. The specific required magnetic field time size product is approximately 10 exa-Gauss parsecs. The specific astrophysical objects capable of meeting this criterion are few. The specific most powerful radio galaxy jets objects like Centaurus A, approximately 13 million light years from Earth, the specific closest radio galaxy, have the specific magnetic fields and specific physical extents that approach this requirement, the specific cores of specific powerful blazars, the specific magnetospheres of specific millisecond pulsars or specific magnetars undergoing specific special conditions. But meeting the Hillas criterion is necessary, not sufficient. The specific actual acceleration mechanism, the specific way in which a specific particle gains energy in a specific astrophysical environment involves specific magnetohydrodynamic processes, specific plasma instabilities, specific shock structures, and specific turbulent magnetic fields that are not fully understood even in specific simpler environments. The specific multi-messenger program combining specific cosmic ray arrival directions with specific neutrino source identifications and specific gamma ray observations of specific candidate sources is the specific most powerful tool for determining not just which specific objects accelerate particles, but how they do it. The specific ratio of neutrino to gamma ray emission constrains whether the acceleration is hadronic, involving specific proton-photon, or specific proton-gas collisions, or leptonic, involving specific electron acceleration without significant proton acceleration. The specific energy spectrum of the neutrinos constrains the specific spectral index of the accelerated proton distribution and the specific target photon or gas field density. The specific answer to how ultra-high energy cosmic rays are produced will be one of the specific, most important results in high-energy astrophysics of the coming decade, not just because it resolves a specific observational mystery, but because it constrains the specific physics of particle acceleration in the specific, most extreme magnetic and gravitational environments in the universe. Let me now connect the cosmic ray story to the specific, broader theme of this series, the specific way that every specific observational window on the universe reveals a specific, different, and complementary aspect of the same physical reality. Throughout these conversations, from gravitational waves to fast radio bursts to the cosmic web to the cosmological constant, we have been building a picture of a universe that communicates through specific multiple channels simultaneously. Gravitational waves carry specific information about mass distributions and their dynamics. Electromagnetic radiation across the full spectrum carries specific information about atomic and molecular processes and the specific thermal and non-thermal emission of astrophysical objects. Neutrinos carry specific information about the most energetic hadronic processes, largely invisible to photons. And cosmic rays carry specific physical samples of the specific material that the universe's most extreme environments have processed and accelerated. Ultra-high energy cosmic rays are unique among these messengers. They are not signals, they are specific physical objects. Specific atomic nuclei, specific actual particles that were created or accelerated in a specific distant environment, traveled through the specific intergalactic medium for a specific measurable time, and arrived at Earth carrying the specific physical signature of their origin and their journey. Every other astronomical messenger is information about distant objects, photons, gravitational waves, and neutrinos that carry specific signatures of the specific physical processes that produce them. Ultra-high energy cosmic rays are pieces of those distant objects, actual matter, that left the specific source environment and traveled here. The specific analysis of their specific composition, whether they are protons, helium, nuclei, carbon, oxygen, or iron, is a specific analysis of the specific elemental material of the specific most extreme astrophysical environments in the local universe. This is an extraordinary thing. The specific Amaterasu particle, before it struck the Earth's atmosphere and produced its specific shower of secondary particles that the telescope array detected, was a specific piece of something, a specific nucleus of some specific element produced in some specific stellar furnace or nucleosynthesis event somewhere in the specific local universe, subsequently captured by some specific extreme astrophysical environment, accelerated to 244 exa-electron volts by some specific physical mechanism, and sent on a specific journey through the specific intergalactic medium that ended in a specific atmospheric shower over specific Utah in September 2021. We caught it. With the specific instruments we built specifically to catch things like it. Let me now tell you what I think is the most personally significant insight that the cosmic ray story provides. Not the specific physics of the GZK limit, or the specific multi-messenger correlations, or the specific composition measurements, but the specific meaning of catching a particle from the most energetic processes in the universe. The specific Amaterasu particle was produced wherever it was produced in an environment operating at specific energy scales that no human technology can replicate. Accelerated by specific magnetic and gravitational fields in a specific extreme astrophysical environment, operating at specific energy densities and specific field strengths that are not available anywhere in the specific solar system. It then traveled through the specific intergalactic medium for a specific time determined by its specific source location within the specific GZK horizon of 160 million light years. At some specific point in September 2021, this specific particle entered the specific Earth's atmosphere over specific Utah. It collided with a specific air nucleus at the specific top of the atmosphere at an altitude of approximately 15 to 20 kilometers and produced a specific shower of approximately 10 billion secondary particles that cascaded down through the specific atmosphere, spreading over an area of several square kilometers by the time the specific shower front reached the specific ground. The specific surface detectors of the telescope array, specific plastic scintillator panels on the specific Utah desert floor, connected by specific radio links to a specific central data acquisition system, detected the specific arrival of the specific secondary particles. The specific timing differences between the specific signals in specific detectors determined the specific arrival direction. The specific signal amplitudes determine the specific shower energy. The specific lateral distribution of the specific shower particles constrain the specific primary particles' chemical composition. And from these specific measurements, a specific team of specific scientists at specific universities in specific Japan and the specific United States and elsewhere reconstructed the specific properties of a specific single nucleus that was produced or captured in a specific environment, more than 160 million light years away, and that arrived at the specific portion of the specific planet on which we happen to live. This specific chain from a specific extreme astrophysical environment through specific intergalactic space, through the specific atmosphere, to specific instrumented detectors, to specific reconstruction algorithms, to specific published science is one of the most extraordinary examples of human reach that currently exists. Not the specific technological reach of space probes. Voyager 1 is approximately 24 billion kilometers from Earth. Impressive, but still within the specific solar system. The specific intellectual reach of cosmic ray physics, catching actual physical objects from specific environments 160 million light years away and determining where they came from, what they are made of, and how they were produced. Let me now close with the complete picture, what the Amaterasu particle, the broader ultra-high energy cosmic ray program, and the multi-messenger astronomy approach it is part of are collectively telling us the universe is not quiet. It is continuously and prodigiously energetic, producing specific particles at specific extraordinary energies through specific extreme physical processes in specific extreme astrophysical environments scattered throughout the specific local cosmic web. It has been doing this for the specific entire history of the universe, and it is doing it right now at this specific moment as you encounter these words. some small fraction of these specific, extraordinarily energetic particles happen to be traveling in the specific direction of Earth when they are produced. An even smaller specific fraction survive the specific journey through the specific intergalactic medium without losing too much energy to the specific GZK interactions. Of those that arrive, an even smaller specific fraction happen to arrive at the specific moment when the specific instruments we have built are operational and collecting data. We catch approximately one event above 100 exaelectron volts per year, approximately one event above 200 exaelectron volts per decade. These specific events are the specific tip of the specific most extreme cosmic ray iceberg, a specific tiny fraction of the specific population of ultra-high energy cosmic rays arriving from the specific local universe. Each specific caught particle is a specific scientific treasure, a specific data point in the specific building of the specific statistical case that will eventually identify the specific sources, constrain the specific acceleration mechanisms, and characterize the specific composition of the specific most extreme cosmic radiation. The specific Amaterasu particle is the specific most recent specific addition to this specific treasury, the specific second highest specific energy event ever detected, pointing toward a specific void, raising a specific question that the specific telescope array times 4 in IceCube, Gen 2 and CTA and Poema are building to answer. It broke the speed limit. Not by exceeding it, nothing does, nothing can, but by approaching it more closely than any macroscopic object we have ever detected, by carrying the specific kinetic energy of 244 exaelectron volts in a single specific nucleus, by experiencing the specific time dilation of a Lorentz factor of 250 billion, compressing the specific 160 million light-year journey to a specific few hours of proper time. And by arriving here, at this specific planet, at this specific moment in the specific history of this specific civilization, when the specific instruments to catch it existed, when the specific scientists to analyze it were trained, when the specific theoretical framework to interpret it had been developed, when the specific multi-messenger program to correlate it with specific neutrino and gamma ray observations was operational, the specific universe has been producing these specific particles for billions of years. The specific instruments to detect them have existed for approximately 60 years. The specific capacity to reconstruct their properties with the specific fidelity of the current generation of detectors has existed for approximately 20 years. We are living in the specific epoch when we first developed the specific capability to catch these specific messengers from the specific most extreme environments in the specific observable universe and begin to read what they are telling us. That specific capability, the specific combination of instrumentation, theory, computation, and international scientific collaboration that the specific ultra-high energy cosmic ray program represents is one of the specific most extraordinary things the specific human species has accomplished. Not the fastest thing, not faster than light, nothing is, but the specific closest approach to the speed limit of the specific universe that any specific macroscopic object we have ever caught and characterized has achieved. And in that specific approach, in that specific 244 exaelectron volts of kinetic energy in a single nucleus. The specific universe is showing us something specific about what is possible in its most extreme environments. Something that no specific human accelerator can replicate. Something that the specific instruments on the specific Utah desert floor can catch, and that the specific scientists can read, and that the specific multi-messenger program can eventually trace back to its source. The specific mystery is real. The specific program to solve it is operational. The specific answer is coming. And when it arrives, when the specific source of Amaterasu is identified, when the specific acceleration mechanism is constrained, when the specific composition is measured with the specific precision of the next generation of detectors, it will tell us something specific and important about the specific most extreme processes operating anywhere in the specific observable universe. Not who did this, what did this, and how. And that specific answer will be worth every specific photomultiplier tube buried in the specific Antarctic ice, and every specific scintillator panel on the specific Utah desert floor, and every specific graduate student who spent specific years learning to reconstruct specific cosmic ray showers from specific sparse timing signals. The universe sent a message. We built the instruments to receive it. Now we are learning to read it.